So as Chris already told you, this AZUG session is brought to you by LoQutus. It's a bit of a different experience, of course, because we would have liked to welcome you in our offices in Ghent, but a tiny little virus put a stop to that. But I'm sure that we'll be able to repeat that in the very near future. So for today, my talk is titled From TFS Trenches to DevOps Modern Warfare. Quite a bombastic title, but it's a story I really want to share and we as LoQutus really want to share. I'm just going to make sure I'm on the right screen. Yep, here I am. So who am I? My name is Thomas Vandaele, as you would say in Flemish, but the friendly Skype lady who announces when you go into a Skype meeting always butchers it as Thomas Vandaele, so you can also call me that way. I'm a consultant at LoQutus, which means my title is .NET Solution Architect, so I still do a lot of development. I do some technical project management, and I do some mentoring and guiding for people and teams. Apart from that, I'm also the .NET/Azure Guildmaster. The guilds are something inside of LoQutus, which is our knowledge centers. So we use it to do some research tracks into a specific subject or do some hackathons. And so we have one guild dedicated to everything that is .NET and Azure. I have full stack tendencies. I wouldn't call myself a full stack developer, but I definitely have tendencies. So I'm interested in backend development, front-end development, but also in everything going from networking to infrastructure to machine learning, even Bitcoin if I'm in a bit of a fad mood. You can find me on Twitter. My handle is there, but I'm not that active on Twitter. Every year I make a New Year's resolution to be more active, but for now I'm only using it to complain to my ISP when my internet is slow or not working at all. My email address is also there if you have any questions for me after the talk, or if you just want to reach out and contact me, you can do that. Who are we? Who is LoQutus? I'm not going to spend a whole lot of time explaining that. You can just go to the site and everything is explained there. We're an IT consultancy firm. We specialize in a couple of subjects or teams, which you can see here. And the team that I'm a part of is the .NET team, the Microsoft team. And we're mostly active in the app modernization section and in the customer experience and engagement section. What that means is we help customers to upgrade their existing .NET solutions. Some of them are pretty ancient, some of them are more modern, but we help them in modernizing those solutions. So by bringing them to the cloud, by bringing them some sort of hybrid infrastructure. And in our customer experience and engagement section, what we mostly specialize in is in customer-facing portals. That's both B2C and B2B portals. Anyway, before I get into the meat of the talk, I first want to ask you some questions. This is the live interaction part of the talk, but I've been informed that there is a 10 to 30 second delay on the stream. So I'm asking you these questions now. I want to know what software or what product you are currently using for source control, work management, issue management. Is that a TFS on-premise instance? Are you using Azure DevOps? Are you using something else like GitHub, GitLab, Bitbucket, Jira, whatever there is? And a second question is also, what specific version control system are you using? Are you using Git? Are you using Team Foundation version control or something else? Mercurial, Tortoise SVN, whatever there exists. Just type out your answers in the chat. I should be seeing those coming in about 30 seconds. So what am I going to talk about? Well, I'm going to start today with some story time. I like telling stories, I like telling funny stories, and I like exaggerating. You can ask my colleagues about that. It will be a very exaggerated story. It will be a horrible story. It will be a traumatic story. I'm hoping I won't cause any PTSD for anyone. but I'll start with the story just to illustrate where we were, where LoQutus was a couple of years ago. After that, I'm going to spend some time talking about 3 big parts of any team, of any organization, of any group of people, and that's the people themselves, the processes they use, and the tools they use. And then I'll zoom in on our specific story, the story of LoQutus and the Microsoft team at LoQutus. I'll tell you what we did, why we did it, and how we went about doing it. And to end the talk, I'll talk about what's next for us, what we're doing right now, and what we're hoping to be doing in the short to mid-term time. I'll just pop open the chat for me and check. Lots of Git users, very good. DevOps, an on-premise TFS user. Okay. Lots of people using DevOps, perfect. So I won't have much new to tell you. So first of all, I want to take you back in time and back to an imaginary world. It's a fictitious story. And as I said before, very exaggerated. But imagine that you are a junior developer and you've just started working for the hot new hip startup called Uber, Snapstagram, Chat, something. You started working there like a month and a half ago, so you've spent 3 sprints there. There's a small team of about 10 developers and nothing else. There's no operations people, only developers, because of course the more developers you throw at a problem, the faster the problem gets fixed and the better it gets fixed. And we're in 2011, so of course we're still using Team Foundation Server 2010. An on-premise solution. So you've been here for about a month and a half. First couple of weeks you've spent digging through the code, getting to grips with the solution. And in the past sprint, so for the past 2 weeks, you were assigned a feature to implement, and that's what you did. And one of the senior devs reached out to you and told you, hey, I'll just call you Thomas for now, because that's a very good name. Hey, Thomas, it's your turn to do a release of the application. Everybody has to do it. Everybody has to know how to do it. And since you're the new guy on the team, it's your job to do it. So in Friday evening in March, somewhere in 2011, I'm sat at my computer and it is 10 p.m. And I've been deploying the new application for the past 3 hours. Why is that? The deploy is not going well, as you can tell. Well, I was given a release manual, but it is what I would call a vintage first edition. It's from 2 years ago. It hasn't been updated in about 1.5 years. It mentions servers that don't exist anymore. It mentions folders that don't exist on the server. There's even some partitions in there that don't exist anymore. So I'm pretty much left to my own devices to figure out where do I deploy this thing. I've already managed to deploy it once, and that worked. I could copy over the files. The new version was there. I made a backup. But when I tried to navigate to the application page, web page, it failed at runtime because one of my colleagues had checked in a feature that required some changes to the entity classes, and he updated those entity classes, but he forgot to document his DB changes. So he didn't check in any SQL scripts or migration scripts. So yeah, that was not very good. And on top of that, my VPN connection is very laggy, and every 15 minutes I get thrown out of my RDP sessions and I have to log back in. So for the past 3 hours, I've just been struggling to do this. I've been copying and pasting files. I've seen some traces of people who've gone before me. They had also backed up the application files. This is probably very relatable for some people. There's a backup folder there from the time when Tamagotchis were still a thing. There's some really desperate names in there. I'm not the first one to have had this problem, but I am the victim right now, and I am just tearing out all the hair on my head. I just want to go home and have a beer because Corona is not a thing yet. So I'm boiling with rage. I want to punch someone in the face. I want to punch a hole in the wall. I seriously want to hurt someone. But I'm left wondering, how did we get here? How did I get here? How did we as a team get here? And well, it all started with a new feature 2 weeks ago. The branching strategy that we use, it said that I had to create a new branch to implement the feature that was assigned to me. And when I say branching strategy, I mean I overheard a senior developer talking about it while I was getting a coffee at the coffee machine. It wasn't documented anywhere, not in documents, not in the wiki page. So I tried to create a new branch, but seeing as this is Team Foundation version control and our solution is 2 gigabytes in size, I've just been struggling to really create the branch. I have somehow managed to get 3 different workspaces on my workstation, and I've been able to get the latest version of my branch into 2 of them, but both of them were the wrong ones, so I've just been struggling with that. So after a while, I just say, screw this, I'm just going to implement my feature on master. That's the only branch anyway that's got automated builds anyway, so why not? So I set about implementing my feature. I check it into master, and then I overheard somebody saying that, yeah, we do code review here. So just when you're ready to have some code reviewed, just ping out to someone and they'll have a look at it. Yeah, that didn't go as well because I used the Team Foundation 2010 feature asking for code reviews. And I don't know if any one of you has ever used that, but it's quite cumbersome, not really intuitive. So I have sent out lots of requests to have my code reviewed, but nobody's taken them up. Nobody's seen my code. They just signed off on it and said, yeah, it'll be okay. I don't know if they don't have the time to do it or if they don't care. By the way, I mentioned on the master branch, we have automated builds. And I don't know if I can, if someone in the audience knows what automated builds looked like in the older Team Foundation services. They were defined using XAML. And XAML is a very different kind of beast. You have to coax it into doing what you want to do. You have to wait until the moon is in the waxing gibbon phase. You have to burn a specific type of incense candle. The candles have to place a specific distance apart. And then, and only then, can you edit, make an edit to a XAML file, and it will not break. Every single other time, you're going to break it. I don't want to scare anyone or cause post-traumatic stress disorder, but this is what a XAML file looked like. It's built on top of XML, which is already, I mean, it's a declarative language to describe an imperative process of building something. It was just, I don't want to spend too long on it. It was just, it was hell. It was, yeah, countless sleepless nights were spent because of XAML. Anyway, luckily that was in 2011, and of course Microsoft would never repeat that mistake of making like an unreadable data format that was opaque. You couldn't test it, even though, yeah, I don't know if anyone's been using Azure as of late, but the way to provision infrastructure on Azure was for a long time only possible using ARM templates, which is a JSON-based data format, which is as worse as XAML, if not worse. It's just you want to do stuff to people that is not very good. So we're stuck with that as well. Anyway, we've got our changes checked in. It's time to prepare the deploy. So what's the next step? We have to merge some things because, of course, there's 10 people on our team. There's other people that also did some work this sprint, and we have to merge their changes. And as I said in the beginning, one of our colleagues, I'll call him Randy. Sorry for any Randys listening to this talk, but he's the guy who updated the entity classes, but didn't check in migration scripts, didn't check in SQL scripts to do the same. So if you're lucky, you spot that error right now when you're preparing to deploy. I wasn't so lucky. I only spotted it at runtime. But hey, you spend a couple of hours merging, fixing merge conflicts, and at long last, we've got a build package ready to go. Only that's not the end of it. we still got some config files that need editing because we're deploying to the test environment, we're deploying to the production environment. We need different configuration for those environments. And I mean, you can use config transformations, and we still do at LoQutus, but there's a couple of problems with that. You deploy them to the server, you do some manual changes on the server, but you forget to check them into source control, so they go out of sync. There's also the problem of storing secret information in those config files. We have sinned and we have put passwords in clear text in our config files. So it's very much possible, but it's not best practice and it's not very safe. Anyhow, so we're back to our deploying, 7 p.m. Friday night, March 2011. And damn it, I want to start my deploy, but our super secure VPN software has just had a new update, and now it requires a Java runtime version that's only 3 major releases old with lots of security bugs in it. But we've set up the VPN connection. We've managed to set up an RDP connection to the server. We have had to go check in our KeyPassDB file for a username and password. There's of course only one user to log into the server, so that we don't know who did what. And as we're a good boy, we make a backup folder. We put the old version of our application in there, and then we start the copy of our files, and we are good to go. That is until the copy of our 2 GB solution, our application, fails because our VPN connection drops out again. As I said in the beginning, it's a hugely exaggerated story, but I think, or I hope, or I fear that most of you can recognize some things that are very relatable. You've probably had some of the same issues, maybe not as bad as I've described them, but this is a situation that is very recognizable, I think, for every developer. So how did we get here? How can someone get in that situation? How can a team get in that situation? And I want to zoom out a bit and look at the different parts that make up a team and what happens there. One of the things that as a team you have are processes. These, for example, this is where we document how we do our deployments, how we code. Our branching strategy is a sort of process that we should define. How we test things, how many unit tests we write, how many integration tests we do. Sometimes these processes exist as verbal folklore. They are shared among a group of people, maybe a core group of people in your team. But if you, as a new developer, come into that team, there is no way for you to learn those processes or what they are, except for talking to those people, which is something you should do and you could do and you have to do. But it is always better to document these processes as they are and put them in writing. It should be very clear why they exist. If people are expected to execute a process in a specific way, and they start questioning, why am I doing this? They will not do it, or they won't do the best job of it. So for each and every process, you have to think about, is it essential, is it necessary, and is it clear? So for example, in my little horror story that I told, what went wrong with regards to processes? Well, there wasn't a clearly defined release process. We had a release manual, but it wasn't kept up to date. It was version 1.0 from 2 years ago, so that was not good. There was no documented branching strategy. So as a junior developer, I was expected to know how people branch, what we do. Do we work with feature branches, topic branches, release branches, hotfix branches? It should be written down. There was also no onboarding process. When a new developer starts in a team, you're supposed to grab them and take them with you, make sure they have a mentor. I was just left to my own devices in that story. Another process that was lacking was there was no separate operations team. Developers had to do the deployment because it was a startup. Of course, I'm not saying that you have to have an operations team, but it is a possible process that you can implement if you have the time and resources to do it. Another part of the puzzle are the tools we use. For example, what are some tools we use as developers day in, day out? That's our code editor, our integrated development environment, our debuggers that we use, our issue tracker, our work tracker, even the VPN software is a tool we use. And those tools, they should work and they should help people while they're executing the processes that have already been defined. They should definitely not hinder them in doing those processes or following those processes. And if possible, these tools should be left as individually as possible. So for example, our code editor, everyone has their own preference. You can use full-blown Visual Studio, you can use Visual Studio Code, you could even use maybe JetBrains to develop some .NET code if you're really masochistic. But it should be left up to the individual to choose what tool works best for them. Only tools that are shared by the team should be common. So for example, the issue and the work tracker is something that should be common. So what went wrong in the story with regards to tooling? Well, for example, the tool we were using, Team Foundation Server, the code review there was hugely clunky. It was your responsibility as the developer implementing something to go out and request a code review. It was not possible to just check in your code and have some bells go off with some senior devs and they were notified that someone, a junior dev, had checked in something that needed review. Another example was I was able to implement my feature straight onto master. There were no policies defined that prohibited me from checking in. Now, I'm not saying the tool didn't allow it, but it wasn't implemented in this story. And again, some tools allow those types of policies, but they're really hard to find and to implement where the configuration has to be done. And of course, VPN software is probably one of the most notoriously buggy software or tools we have. So it would be better if you just didn't need the VPN software at all, if you had some sort of automated release builds. And the last piece of the puzzle, most important piece, which is why I've put it nice and big, is the people. The people are the ones doing the work. They are developing, they are executing the processes, and they are expecting the processes to be clear and concise, and they are expecting tools to aid them as easily as possible in those tasks that they have to do. If tools do not aid them, or if they struggle with the tools, they will be losing time, and they will be losing focus, and they will be losing hope after a while. So it's very important to think about your tools, which ones you're using, and your processes, how you define them, how you follow them, and just what they are. So as I said, the story is based in reality. It was exaggerated hugely, but a couple of years ago, we found ourselves in a similar situation at LoQutus. So we took some time to look at these three parts and decide what to do. And we focused first on the process. And while researching this, we came upon DevOps process, the DevOps process. I've just yanked the definition from DevOps from Wikipedia here, even with footnotes and everything. You can read it yourself. So DevOps is a set of practices that combines software development and information technology operations, which aims to shorten the system's development lifecycle and provide continuous delivery with high software quality. So that's a lot of big words that are not saying much. So I've put it in my own words. What is DevOps? For me, DevOps is where you make it go fast, you make it go automatically, and you make sure it's documented. And why do we do those things? Why do we use DevOps? Because we want to provide value faster for our customer. We want the value that we deliver to be of better quality. And all in all, we just want our developers and all the people on our team to be more happy. Happy developers means better quality, means more work done. Small tidbit, the practices that are defined in DevOps are not new. It's just a bit of a rebranding and repackaging, but it was actually rebranded and repackaged right here in Belgium. The first thing I could find about DevOps is in 2009, I think. someone in Ghent who organized the first DevOps days. Just a small tidbit of information. So again, I went to Wikipedia and I tried to find a list of processes that are defined in DevOps, and they are defined as follows. They are quite linear in time. So you start with coding, the coding process. What happens in coding, it defines your version control system, how you code, it defines your branching strategy, it defines how you do code review, it defines your coding style. And again, what went wrong here in our story is, for example, there was no code review. Branching was, the strategy was unknown to me as a junior developer, and branching was also very expensive and time consuming. That was because of the tool we were using, Team Foundation Server. Same thing goes for merging. Merging in Team Foundation Server is also quite a time consuming activity. Second process in DevOps is building your application. What went wrong here in our example, I was able to build the solution. It built without errors, but when I went to the application at runtime, I got an error because our SQL changes hadn't been executed on the database server. So what are we missing here? We were missing some sort of integration tests. That's another process. You can have unit tests to test the functionality of your code, but you can have integration tests to make sure that when your application actually talks to the database, that everything is all right as well. So if you have entity classes that have been updated, but our SQL database or SQL database hasn't been updated, an integration test could catch that. After we've coded our application, built it, and tested it, then we're ready to go on to the packaging process. Packaging our application means having a small block of code, a package that we can push to several different environments. So we have one package that we first release to a development environment where it's tested by us and others. Once that's been found to be good and have no more issues, we push that same package to a test environment. And once it's passed all tests there, then we can push that same package onto the production environment. So very important here is we have the exact same code that passes in all three environments. The pushing of that package to the different environments is, of course, the releasing process. And in that releasing process, you can do a couple of things. And one of them is also configuring your package to a specific environment. So this means plugging in specific configuration variables specific to the environment you're deploying to. And a last process in DevOps is monitoring our application, both after we've deployed, but also continuously as it is running, to have an idea of, is it still healthy? Did we introduce any memory leaks or something? We have to be able to see that that is happening and plug into it. So those are the 7 processes that we've distilled from DevOps and that we decided to focus on in LoQutus. So I'll be using this tree of processes to describe the journey that we took. So the state of the Microsoft team in LoQutus in 2011, so the year our story took place, is with regards to the coding process, we had a Team Foundation 2010 server on premise. There was really no formal code review process. And with regards to a branching strategy, we had our typical main branch, dev branch, and feature branches. So that worked pretty good. For building, we had some automated builds that were defined in the cursed XAML format, which I will not spend any more words on. But we also had some projects that had to be manually built. This had a couple of problems. For example, one of our projects, which was a solution that was deployed to SharePoint, so it was a SharePoint package. Our development environments were based on a virtual machine because we didn't want to run a SharePoint server instance on our local machines. So we had been using those virtual machines for a couple of years, and when we had to build something to release it, we always did it on those virtual machines. The problem we found when we migrated that solution to an online environment, which would be the Azure DevOps, that our builds failed immediately, because a certain dependency, a DLL file, was not included in source control. So for, I think it was 4 or 5 years, there was a DLL that was required by our solution that only existed on those development virtual machines. So that's just one of the problems you can run into if you do not have some sort of automated build pipeline. With regards to testing in 2011, it was 9 years ago, we weren't that rigorous yet. We did want to write tests. We saw the value in it, but we only did it when we had some spare time. We weren't very experienced in test-driven development. And even when we did write tests, we had no continuous integration pipeline. So it was always the responsibility of the developer checking something in to run all the tests in the solution to make sure that they didn't break anything. And of course, when things have to go fast, it is very easy to just forget that. With regards to packaging, we didn't really do packaging. We didn't see it as a separate process. For us, building something was making a package. We built it in release mode if we were lucky, but there were some instances where we deployed an application that was built in debug mode to the test environment, and sometimes that even went as far as into production. And releasing, of course, was a pretty manual process. So we had to manually set up our VPN connection, manually RDP into the application servers. Then we would copy over our files. And then we had automated it a bit. We wrote some batch scripts to do the copying, so making a backup and then copying the new files. But one of our batch files, and this is a true story, it's still in use today, looked like this. So the details are not important. It copied some files to a backup folder, and then it replaced the new files. And at the end, it printed some very nice ASCII art of a check mark. So you knew everything went well, it was a check mark. Except it didn't. Even if something went horribly, horribly wrong, the check mark would be printed to the console output. So yeah, even those batch files weren't really perfect. With regards to configuring our solution, we were using config transformations. So something you definitely know. So you have your web.debug.config, web.release.config. You may even have some web.tests.config and web.production.config files. We were doing that, but we had the problems that you always have with something like that. We did some manual adjustments on the servers. We forgot to check that into source control, so those configuration files went out of sync. So when an issue occurred, we sometimes had to spend half an hour or an hour just comparing the two config files to make sure that they were the same. And with regards to monitoring, the only thing we really had from our application was we logged to files and our table. Of course, we did use a logging framework. We used the Microsoft Enterprise Library logging block, but that was about it. Sometimes we would create a custom dashboard in the application where you could see the last 200 log statements, or you could filter on the errors. But if you wanted some more information, you really had to, again, set up your VPN connection, connect to the database server, and then perform your queries. So I just want to be clear, it worked. It worked in 2011. It worked for many years after, but it was not ideal. Then in 2015, while Taylor Swift was shaking it off and Bruno Mars was promising us Uptown Funk would give it to us, something changed. We got a new TFS server. We managed to get a project from a customer who already had some source code, and they wanted to give the source code to us and just say, it's your responsibility now, we want you to host it. And that source code was hosted on a Team Foundation 2013 server. So we installed one, and that was that. We did not migrate our existing projects to that new server. And every time a new project started, there was really no clear choice on if you would add it to the 2010 server or the 2013 server. Why was that? Because nobody had the time or the hope or the soul left to create some new XAML builds on that TFS 2013 server. So none of the projects that existed there had automated builds, just because nobody had time to do it. Our testing had actually evolved quite a bit over the past 4 years. We had made some changes to our general solution architecture, which we always try to implement on new projects. And we had started doing some test-driven development. So we wanted everything to be unit tested. We wrote some integration tests to make sure everything had everything passed and everything worked. All the rest of the processes stayed the same. So all in all, in 2015, nothing much happened except that there was quite a lot of confusion. So again, to be clear, it worked. It definitely worked. It worked for a couple of years. But in 2017, we saw the opportunity to do something new, to change something up. And what we had was we scored a couple of new major projects, and we decided, okay, we're not going to do this on Team Foundation on-premise service anymore. We want to do it on something new. What we did was we did not go to management and ask them, can we have 10 days, 20 days to set this up? We did not ask our customers to pay for it, because they would have just said no, because we couldn't explain to them that the time we spent setting up this new tool right now will save us a lot of time in the future. They wouldn't believe us. So what we did is we just did stuff in small steps and gradual steps over a long period of time. And we made use of the technology and tools that were available at that time in 2017. And those tools were a lot better than what they were in 2011 or even 2015. So biggest change was we decided to set up our new projects in Azure DevOps. Only it wasn't called Azure DevOps then it was still known as the Visual Studio Team Services. Before that, it was known as Visual Studio Online, which was a horrible name choice by Microsoft. And even before that, it was called the Team Foundation Service, which was basically a cloud-hosted Team Foundation server that you could use. Why did we choose DevOps? It was because at that time, it had already been, it existed for 5 years at that time. And what we've seen with Microsoft products is that after a couple of years, 3, 4, 5 years, the products they put out actually start being usable and in a good state. For example, SharePoint. SharePoint 2007 was just a train wreck. SharePoint 2010 was a big improvement, but still And from SharePoint 2013 onwards, it started being usable. So DevOps was in 2015 at that stage where we were comfortable making the choice and trying to use it as our daily driver. Good to mention is at that time, we were still using Team Foundation version control, so no Git yet. So for example, GitHub or GitLab or Bitbucket wasn't really on our radar yet, wasn't really an option. So we set it up in DevOps, and oh my God, revelation, to set up automated builds in Azure DevOps, team services at that time, was just a miracle. You had a visual editor where you could drag and drop out of the box tasks. You could configure those tasks. It was clear what they were doing, and you could just set it up and have your builds hosted on a shared build agent. You even got some free build minutes from Microsoft. You didn't even have to pay anything to get started with DevOps. So that's what we did. For our new projects, we set up a continuous integration build, which always ran every single test. And we set up a release build that would package our solution into something that we could easily deploy to a environment or server. So for testing, the continuous integration build was a godsend because every time someone checked something in and one of the tests failed, they would get a big, huge red check mark above their head, and we could all go and yell and scream at them until they had fixed their shit. With regards to packaging, releasing, and configuring, at that time in 2015, there wasn't really, I mean, you could do it in Azure DevOps, but that was still in its infancy. Build pipelines were very advanced already, but the release pipelines still had some things lacking. So that's why we decided to go for a third-party tool to do that. And at that time, that was Octopus Deploy. So the way it works is very similar to other release management tools like Jenkins or something. Is you have a central server, the Octopus server, where you define your releases. So our build pipeline in Azure would build something, make a NuGet package of it, and then push that to our Octopus server. And in Octopus, we could say, we want this build package to be released on that development environment, and we want to use those configuration variables. That meant also that the manual step of logging into the server was no longer there. So that was a huge time saving. You just installed a small piece of software called an agent on your servers, and those agents could communicate with the Octopus central server as long as they could connect to the internet, and everything happened automatically for you. Even if your application servers didn't have a connection to the internet, it was still a godsend that you could just go to the Octopus server, download a pre-packaged deployment package, and just copy that to the server and do it manually. And it was all done for you. And with regards to monitoring, we also started using in our solution architecture structured logging, which is not something I want to go into right now, but suffice it to say, it was a huge help in the monitorability of our solution and in tracing down issues when they came up. Also worth mentioning is this was in early 2017. Not long after that, there was a huge release to release pipelines in Azure DevOps. And what Microsoft did was they just copied all the best parts from Octopus Deploy and just put that into DevOps. So we were just a bit too early to get on that train, but we managed to do that the year after. Because in 2018, what we did, that was a year of innovation and experimentation. So what we did in the projects that already existed in Azure DevOps, we made the decision to go from Team Foundation version control to Git. Why did we do that? For one specific project, it was a requirement of the customer. They wanted us to use Git. But more importantly is, but I'll get into that later. First, I'll say how we did that. So to migrate from Team Foundation version control to Git, either from DevOps to DevOps or from an on-premise server to DevOps, you've really got two options. There's an open source tool that you can use, Git TFS, which you can point at a TFS repository, and it will just make a Git repository out of that TFVC repository. What's good about this tool is it's very powerful. You can get the complete history of your Team Foundation repository, including all branches, if your branching is not too complex. And what's also good, something which we also used, is that when you have that Git repository, you can keep the Team Foundation repository and the Git repository in sync for a while. So when people are doing check-ins in TFS, you can sync those check-ins to the Git repository. Biggest downfall of that tool is that it is just very slow. What it does is it calls some APIs that are provided by Team Foundation server, and it manually goes over every check-in one by one, and for each check-in it creates commits and then commits that to the repository. So if you've got a repository that is, I don't know, 2-3 years old, the migration with this tool can easily take a couple of hours, like 5-6 hours. Another good thing about this, though, is you can use it down to Team Foundation Server 2010, which we used. Because the second option is actually built into DevOps. If you have a Team Foundation repository in DevOps, then you can just migrate it to a Git repository with some out-of-the-box functionality. Great thing about that is it's very fast, it's very easy. Biggest downfalls is you're limited in the amount of history that you can take with you. So that's 180 days or 6 months. For some of our projects, that wasn't a problem, so we used this. Of course, this means that you have to have your Team Foundation repository in DevOps already. And to get your Team Foundation repository from an on-premise server into DevOps, I think you have to have a minimum of Team Foundation Server 2013. There's tooling included there to copy the repository up to DevOps. I'm only talking about the code repository. I'm not talking about the project templates and everything and your XAML build files. Those are all things that you have to do manually. We also have no idea how it handles complex branching scenarios because we didn't use it. This is the UI for that. So in your DevOps interface, you go to your repositories tab. You say, I want to import a repository. And there you say the repository type is Team Foundation version control. You give it a path, so you can specify a path down to one single branch that you want to migrate. Or if you take the root path, it will try to migrate all of the branches that are below that path. The interface isn't that good because in the field where you specify how many days of history that you want to add, there's like no validation on it. You can just put everything you want in there, and only when you press the go button will it say that you tried to get too many days of history. So that's what we did in 2018. We migrated from TFVC to Git. And one of the things we did that for was because we wanted to start using pull requests. People who are used to hanging out in the open source community on GitHub already know what this is, but a pull request is a tool you can use if you've implemented a feature on some code base. You can ask for your feature to be merged into a master branch. And Azure DevOps has actually implemented it in much the same way that GitHub does. And how we're using those pull requests is as a code review process. So everyone who implements something on a separate feature or topic branch has to create a pull request to get that merged into master. The good thing about pull requests in DevOps is that you can put policies on your branches which say that a pull request cannot be completed if, for example, you don't have a successful build or if any tests fail. So that means nobody can commit or check in any broken code to the master branch anymore. It has to go to a pull request. The web UI for the pull requests is also a godsend. You've got a centralized view of all the changes in that pull request, a nice diff view as we've come to be accustomed to. It's just all around great to have those pull requests. What we also did in our pipelines, so in our build pipelines, we updated them to work for both our front and our backend. So for our front-end development in our newest projects, we're also always working with a single page application and Angular, which means to build that front end, we had to execute some NPM scripts. Luckily, build pipelines in DevOps have no issue with that. You just run npm install on a build agent. It gets everything down, and then you build your project. In the testing process, nothing much changed. And in packaging, we actually switched from Octopus deploy, which we were using before, to the Azure pipelines, so Azure release pipelines. For configuring or updating our configuration files per environment, we use the same technique that we did in Octopus deploy, where we have a DevOps specific configuration file, which has a bunch of placeholders, and then at release time, we copy those placeholders, or we replace those placeholders with the values that are specific for that environment. And monitoring in our applications, we also start using Azure Application Insights, which is just a great way of having some real-time metrics coming out of your application out of the box, like memory usage, CPU usage, number of HTTP requests, and you could also use it to monitor some application-specific, business-specific events. So that was the first half of 2018, where we did a lot of innovation and experimentation. And in the second half of 2018 and all through 2019, we just went into a sort of execution phase. We had done all these things multiple times now for several different projects. So we just decided to migrate all our existing projects to DevOps. So we still had some projects in TFS 2010, in TFS 2013. We just migrated all of them to DevOps. In building news, in 2018, I think it was in September, Microsoft actually upped the amount of free build minutes that you could get, which means that now you get, I think it's 1,800 minutes per month. So that's a lot of hours of build time that you just get out of the box for free. In testing, not much changed because it was working well and we were confident in our tests. Packaging as well, release pipelines, we just kept using them, kept defining new ones for the projects that we were migrating. In our releasing pipelines, we actually added a few tasks. So we automated all of our database changes using Alias SQL, which is just a tool that can automatically grab some change scripts that you check into your source control and execute them on the server before your application is deployed. We chose Alias SQL as a tool because it fit our process, but of course you're free to choose something else, like DBUp is another tool in that segment. You have Roundhouse, you also have entity framework migrations if you want to do that. And what we also did was we started generating automated release notes, which was very nice for our customers. So every time we made a release, all the linked work items that were packaged into that release, all the bugs that were fixed in that release, they were all automatically added to a wiki page, which we could use as release notes, or we could get a Word document out of it, or just a PDF or something. And in the configuring section, what we did was we finally solved the ancient problem of secrets in config files. Instead of putting our passwords in clear text there, we started using Azure Key Vault to get those secrets at runtime. Again, this is not a presentation about Azure things, but if you don't know Azure Key Vault, definitely check it out. It's perfect for managing secrets and making sure they stay safe. And in the monitoring segment, not much has changed. So that was 2018 and 2019, so the past year. The last project that we migrated, I think, was in November 2019. So that's pretty much where we are at now. So how does our DevOps process look right now in 2020? So with regards to our coding, we have easy and quick branching with Git, which is a godsend over TFS. We have code review that we can enforce very naturally using pull requests and policies on our branching. In our building segment, we have continuous integration builds that run every test every time for each pull request. We have our continuous deployment build. So if we trigger one of those, our solution is built and it automatically goes into a release pipeline and is automatically deployed to a development environment. With regards to testing, we are still using a good mixture of unit and integration tests. We're still experimenting there, as everyone is, I think, about what the right amount of tests is, what things you should test, what things are not worth testing. For packaging, we're using Azure Pipelines all the way, so Azure Release Pipelines. For our releases, the same thing, we're using pipelines. Our database changes are fully automated. Our release notes are fully automated. And for configuring, again, we're replacing the tokens in our configuration files. We're getting our secrets from Azure Key Vault, so that's nice and secure. And for monitoring, we're using Azure Application Insights to get real-time monitoring and also some logging. And our actual logging that we're doing in our application, we're doing using structured logging. So what is next for us? What we definitely want to do, and what we're doing as we speak, is we're investigating infrastructure as code. So that's one thing that we haven't been able to automate yet, or properly document yet. So we're experimenting there using Terraform, which is the newest way of provisioning infrastructure as code. It's available on Azure. And from what I can tell from the past presentations I've seen by Microsoft employees, is that this is the replacement for ARM templates, which I thank God for, because ARM templates is just an even worse version of, for example, XAML templates. So what we want to do there, why we want to use infrastructure as code, is we would very much like every single feature branch to have a dedicated temporary environment where we can do some smoke testing. So that would very much help us for specific projects where some of our customers are very close to the development, where they actually want to test and provide feedback as close as possible to the development cycle. It would be very handy to have that. Another thing is we're looking to convert all our pipelines into the YAML format. What that means is, for now, if you define a pipeline in Azure DevOps, if you do it using the graphical user interface, the web interface, you have to keep on using the graphical user interface. You can also define them in YAML, and you can actually do more things in YAML or do them more easily, but there's right now no way to switch between them. So we're looking to see if we can convert our pipelines easily, but we're also waiting on Microsoft there, because from what we can tell, we're thinking Microsoft is actually working on something where you can easily import a YAML pipeline into the GUI and vice versa, where you can export a graphical pipeline into YAML. We're also looking into expanding on our real-time monitoring capabilities. So right now we have our Azure Application Insights, where you can have a dashboard in your application portal. But for some of our projects, we're actually looking if it's possible to, for example, export some of our logs to an Elasticsearch engine or a Prometheus server, so we can actually have much more dashboards and much more knowledgeable real-time monitoring for our applications. And other than that, we also want to spread the love for not only Azure DevOps, the product, it is a great product, but also DevOps, the practices, the process. We're doing that internally to the other teams in our organization, because Azure DevOps, and especially the pipelines, can actually perfectly be used for non.NET projects. For example, we have a data and analytics teams that is using Python for machine learning and so on. You can very easily build and release a Python project or a machine learning project using Azure pipelines. They're very, very powerful. And also externally, we want to spread the love to our customers. We want to let them know that the choice to work with DevOps is also in their favor. It saves us a lot of time developing, testing, and tracking down bugs. So it saves them a lot of time and money. And we also want to spread the love to the community, which is what this talk is an instance of. And so just a bit of a recap before I finish off, because I've already gone over my allotted time slot. The biggest lessons that we learned during this whole process, which lasted or has been lasting for about 2 years now, and which is still ongoing, is don't go for a big bang. Don't say, all right, we want to migrate all of our projects to DevOps in the coming 2 months or something. Start with one project, just migrate it to DevOps, the code repository, but keep your builds local, then do the builds. Second big lesson is just try to automate everything. So this goes from, for example, the continuous integration build. We noticed that developers were forgetting to run the test suite locally. So don't expect them to remember, just automate it. Do it with a continuous integration build, especially the releases and deployments. Every manual action is an action that can go wrong, and that would be difficult to roll back. If you automate it, it does it fast. You can do it 10 times in a row in exactly the same time, and it is actually self-documenting. If one of our junior devs now goes to the pipeline in Azure and goes through the tasks that we've defined, it is very clear to them how we release, what we do, and what is being done by DevOps. And of course, share your knowledge. While you're doing this, if, for example, you're the first one in your organization to do the migration to DevOps, document what you did. If you use a tool like Git TFS, document what you did, what commands you did. If you set up a pipeline, it's very easy to export the tasks in those pipeline in a JSON format, so that the next person for the different project can just take that JSON and have his or her pipeline ready to go in no time. And just all in all, embrace DevOps, embrace the practice of DevOps. Once you get started doing it, you'll wonder how you ever went without it. Use your own tooling, whatever suits you and your team. But we can highly recommend Azure DevOps as a product. Very easy to get started. It's free. You get 5 free licenses. You get a whole load of free build minutes. You can just make a tenant for yourself, click around, test, and just go out and do it. And that is all I have. Thank you for listening. Thank you for enduring my rambling. And I just want to know if there's any questions right now, although I think they would have come during the talk.